Good afternoon, class. Here's Math 119A, Chapter 1, Sequences, Section 1.6, Sequences and Difference Equations. Sequences and Difference Equations. Here's the summary, 1.6 Sequences and Difference Equations summary. A sequence is a list of numbers written in a specific order, a sub 1, a sub 2, a sub n, the first term, the second term, the nth term of the sequence. Accordingly, a sub n is the general term, and n being the set of natural numbers, also known as positive integers, also known as counting numbers, 1, 2, 3, to infinity. Recursive sequence, also known as difference equation. A recursion or recursive formula defines a sequence by specifying the first few terms of the sequence and using a formula to specify subsequent terms in terms of preceding terms. In other words, the next term depends on knowing the previous one or previous ones, and the form is a sub n plus 1 is f of a sub n. All right, a couple of sequences everybody should be familiar with from basic algebra. One of them is an arithmetic sequence, where the difference d, also known as distance between consecutive terms, is constant, can be defined by. So look at this one. A sub 1 is the first term, then we add d, a sub 1 plus d, then a sub 1 plus 2d, and all the way to the end. So we can define them in two ways. Recursively, a sub n plus 1 is a sub n plus d. This means if you want a term, go to the previous one and add a d. Or explicitly by a sub n equals a sub 1 plus n minus 1 times d. That means in general, any term start with the first one and then n minus 1 times the distance. If you look here, 1, 5, 9, 13. We are adding 4. So the next one is 17 and so on. Similarly, a geometric sequence, a sub 1, a sub 1 times r, a sub 1 times r squared, and so on, where each term is r times the previous one, can be defined again two ways. Recursively by a sub n plus 1 equals r times a sub n. In other words, if you want any term, pick the previous one multiplied by r, or explicitly by a sub n is a sub 1 r to the power of n minus 1. So any term you want, pick the first one, r to the power of n minus 1. So in this case, 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. Times 4 again is 256, and so on. So in this case, we add a constant. In this case, we multiply by a constant. Sequences. A sequence is a list of numbers written in a specific order. Measurements collected at discrete time points and quantities that undergo periodic changes, such as annual plant or insect populations, are studied using the concept of sequences, the data, and difference equation, the description of the mechanism of change. A sequence is a real valued function f whose domain is the set of natural numbers 1, 2, 3 to infinity. We use the notation a sub n to denote f of n. A sub 1, a sub 2, and it continues. The first term is a sub 1. The second term is a sub 2. Generally speaking, a sub n. Start with a very simple example. A sub n equals n. That means if you want any term, just use the number. So if I want a sub 1 is 1, a sub 2 is 2, a sub 3 is 3, and so forth. And so because we want the first 5 terms, given the general term, find the first 5 terms, 1, 2, 3, 4, 5. What about here? Let's replace the n with 1, 2, 3, 4, 5. So if 1 gives us sine of pi over 2, 2 gives us sine of 2 pi over 2, which is sine of pi, 3 sine of 3 pi over 2, 4 sine of 4 pi over 2 or 2 pi, and 5 sine of 5 pi over 2. But what are they equal to? I want to remind you of some information from analytic geometry as well as trigonometry, just to refresh your memory. And remember, if you go to MOM and my Open Math, Module 0, we have the resources, including the chapter review. You can review everything, including trigonometry. All right, so reminding you, this is a circle centered at 0, 0 with the radius r, has the equation x squared plus y squared equals r squared by Pythagorean theorem. X squared plus y squared is r squared. If it's centered at h and k, becomes x minus h quantity squared plus y minus k quantity squared equals r squared. Now, if this one centered at 0, 0 has a radius 1, we call it a unit circle. So unit circle, r equals 1, x squared plus y squared equals 1 squared over 1. Here's the unit circle. It crosses the x-axis at 1, 0, negative 1, 0, crosses the y-axis at 0, 1, 0, negative 1. And as far as the angle that it makes, this one, okay, the terminal side of the angle, it makes with the positive side of the x-axis, that's the angle. So this is 0 degrees. This one is 90 degrees or pi over 2. Pi or 180 degrees. 3 pi over 2 or 270 degrees. And a complete revolution, 360 degrees, brings us back to 0 degrees. For example, 2 pi is the same as 0 in essence, as far as the location of the terminal side. 5 pi over 2 is 2 pi plus pi over 2. It puts us back at pi over 2. Now, what we want to add is the following. Every point has 2 coordinates, x comma y. So every point on a unit circle, x comma y, if you look at this triangle making this angle or arc T, sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and the hypotenuse is the radius is equal to 1. Therefore, sine, the opposite, represents the y, and adjacent represents the cosine. Therefore, x is cosine t, y is sine t. So if we start with this one, we see that cosine is 1, sine and tangent would be 0. In other words, just right here, this point, or this point, or this point, means cosine 0 is 0. My apologies, cosine 0 is 1. Sine 0 is 0. This point has coordinates 0, 1. The angle is pi over 2 or 90 degrees. Cosine of pi over 2 or 90 degrees is 0. Sine of pi over 2 or 90 degrees is 1. This point is located at negative 1, 0 or pi or 180 degrees. Therefore, Cosine of pi is -1. Sine of pi is 0. This point located at 0, -1, or 270 degrees, or 3 power 2. Therefore, cosine of 3 power 2 is 0, and sine of 3 power 2 is -1, which means over here this is 1, 0, -1, 0, 1. And again, remember 2 pi, by the way, if you go back to 2 pi is a complete revolution, takes you back to 0. And as I mentioned, 5 power 2 takes you to pi. A couple of things I want to add. In general, sine of n pi is 0. That means multiples of pi, the sine value is 0. Cosine of 2n plus 1 times power 2 0. Meaning, if you have odd multiples of power 2, the cosine is 0. Okay. So we just went over some information from trigonometry. I hope everybody's comfortable. We're going to move on. Now, we want C sub n equals n over 1 plus n. So simply put, if I want n to be 1, just put 1 here, and 1 here, you get 1/2. If I want C sub 2, I put 2 and 1 plus 2, 2/3, and the rest of them follow. So this was a very, very simple example. D sub n represents the digit in the nth decimal place of pi. And I hope you realize that pi is not equal to 3.14, but rather is approximated by that, which means we have to know pi is 3.14159, and it continues indefinitely. So the first one would be 1, the second one would be 4, and so on. So we write the first 5 terms of D sub n, the digit in the nth decimal place of pi, or 14159. That would be the answer. Find the first 5 terms of the sequence a sub n equals 2 to the power of n minus 4. So a general term is given, and we want to find the first few. So the first one would be a sub 1 is 2 to the power of 1, which is 2 minus 4, -2. If I want the second one, a sub 2 is 2 squared, 4 minus 4 is 0. If I want the third one, is 2 cubed, which is 8, minus 4 is 4, and you can figure out the rest. Find the formula for the general term a sub n of the sequence. And by the way, this is normally more complicated than the other way around. In any event, you should look for a pattern. And I hope you realize 5 to 8 to 11 to 14 to 17, what we are doing, you're adding the same number. And you really have to check with the next one and the next one and next one. So this is an arithmetic sequence with the difference or distance of 3. The first term is 5, the d is 3. That's just by inspection. Now a sub n is a sub 1 plus n minus 1 times d, or d times n minus 1. Replace the a sub 1 with 5 and d with 3. 5 plus 3n minus 3 and combine these two to 2, you get 3n plus 2. Now, it's important to check, meaning this may or may not be right. How do you know that? So check it out. If I replace the n with 1, do I get the first term 5? Yes. If I change the n to 2, 3 times 2 plus 2, do I get 8? Yes. 3 times 3, 9, and 2, 11. I just check, everything works out, and that's how you should do that. You must check your work. I can't emphasize this enough, everybody. Now we're going to do the same thing with this one. We notice this by inspection that if I multiply 1 by negative 1/3, I get negative 1/3. If I multiply negative 1/3 by negative 1/3, I get 1 over 9. 1 over 9 times negative 1/3, I get negative 1 over 27. That makes it a geometric sequence with a ratio of negative 1/3. That means this is the first term, this is the ratio. So we write a sub 1 is 1, or is negative 1/3. And the general term a sub n is a sub 1, r to the power of n minus 1. And so what we do, we replace the a sub 1 with 1 and r with negative 1/3. Now, 1 basically has no bearing, but what I want you to pay attention is that this has a negative sign and this is alternating. You must always, this is the way we work with sequences. We separate the negative sign always by doing the following, everybody. So we're going to say negative 1 to the power of n minus 1 times 1/3 to the power of n minus 1. And here's the reason. This piece in front creates the alternative sequence. Now, it either starts with positive and then negative, positive, negative, or it starts with negative and so on. Now, for alternating sign, start with one of these two, either negative 1 to the power of n or negative 1 to the power of n minus 1, as it's the case here. Notice, if you start with this one, 1 makes this negative and the first term must be negative. But if you start with this one, 1 makes this 0, negative 1 to the power of 0 is 1. Just recall that's the case. Okay. Now, you have to check. And to check, let me just erase my work. We are going to put 1 in here, then 2 here, and 3. I'm going to do one of them. So if I put number 1 in here, I get minus 1 to the power of 1 minus 1, which is 0 over 1/3 to the power of 1 minus 1, which is again 0. Negative 1 to the power of 0 is 1, 1/3 to the power of 0 is 1, and we get 1. That's the first term. I highly recommend you try the second one class. It's really not that big of a deal. You can do that. Okay. So it's very straightforward, everybody. Difference equations. Sequences are sometimes created recursively, specifying the next term given the present. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one. And it may not always be possible to determine the general term of the sequence algebraically. A difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 equals f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. That's it. Definition of a difference equation. So having said that, one of the famous ones is a Fibonacci sequence, where we start with 1 and the next one is 1. And then if you want any term, f sub n equals f sub n minus 1 plus f sub n minus 2, that means if you want a term, add the previous ones. So 1, there's nothing before that, gives you 1. And then now this 2 gives you 2, this 2 gives you 3, and so on. So if I want the next one, I'm going to add these two numbers and I get 34. That's how you get the next one. If I want the next one, I add these two numbers now. 21 and 34, I get 55, and so on. Now, in nature, example in nature, the number of branches increases up a tree trunk according to the Fibonacci sequence. So first year we have 1, then we have 1 again, and the next year they add up to 2, and the next year they add up to 2 and 1 is 3, and the next year they add up to 3 and 2 and 5, and 3 and 5, 8, and so on and so on. So Fibonacci sequence, the sequence I believe everybody is familiar. Now we want to find the first 6 terms. We are looking at a recursive sequence. A sub 1 is given. Some number, in this case, number 6. And we want a sub n plus 1 equals a sub n over n. So that means I want a sub 2, 3, 4, 5. So I need to find a few more. The first one is given. Now, it's important to understand the meaning of it. It means if you want any term, go to the previous one and divide by the location. So if I want a sub 1 is given. If I want the next one, that would be a sub 2. So if I want this one to be 2, this must be 1. A sub 2 is a sub 1 over 1. 6 over 1 is 6. So if I want the next one, that means I want this one to be a sub 3. So I go to the previous one, 2, divided by 2. That means 6 over 2, which is 3. If I want a sub 4, I'll go to the previous one, 3, and divide by 3, which is 3 over 3 equals 1. And I highly recommend you work on these two. Make sure you get the same answer I have here for practice. So that's the first question. Part B, a sub 1 is 1, a sub 2 is 2, and a sub n plus 1 is a sub n plus 1 plus 2 a sub n. Meaning, if you want any term, n plus 2 versus n plus 1, you go to the previous one. So you pick the previous one. Plus, you go to the one before that and you multiply by 2, you add them up. So if I want, so I have a sub 1, I have a sub 2. The next one is a sub 3. So a sub 3, I have 2 ways to go. I can say n plus 2 is 3, and that means n is 1, and I put it here, and this becomes a sub 2. Or I can say just, this is a sub 3, go to the previous one, a sub 2. And then the previous one times 2. So a sub 3 is a sub 2 plus 2 a sub 1, which means a sub 2, which is 2, 2 times 1, 2, they add up to 4. Now, I have a sub 3, that means the next one, this must become 4. So go to the previous one, 3, go to the previous one, 2, and write down a sub 4 is a sub 3 plus 2 a sub 2. So here's the 4, 2 times a sub 2, 2 times 2, 4 and 4, they add up to 8. What about the next one? The next one is 5, a sub 5. If this is 5, this is 4, this is 3. Please understand that. So that means a sub 4 is 8, plus 2 times a sub 3 is 4, 8 and 8, they add up to 16. And try the next one, which is 32 on your A sub n plus 1 is 2 times A sub n minus 4. A sub 1 equals 3. That means if you want a term, go to the previous one multiplied by 2 and then subtract 4. So if I want A sub 2, if I want this one to be 2, that means this one must be 1. So A sub 2 is 2A sub 1 minus 4. 2 times 3, 6 minus 4 is 2. Now, if I want the next one, 3, then this must be 2, right? So 2 times A2, which is 2, gives us 4 minus 4 is 0. And I highly recommend you try finding the rest of it as practice. It's really helpful. All right. Suppose C sub t is the concentration of a drug in a bloodstream at time t. A, the amount of inflow, is the concentration of the drug that is administered at each time step. That means every hour, every 4 hours, every 12 hours, every day, every week, whatever this time step means. This is very important, everybody. And K is the fraction of the drug metabolized or absorbed in a time step. A portion, 10%, 20%, 50%, 70%, some portion, some fraction, some percentage is gone by the time we add more medication. What is the recursion that models the dynamics of drug concentration? I hope you understand that in general, n or any variable that you want represent the amount of the next step, t plus 1. Means the previous amount, whatever it was, we had so much medication in the body of the patient, and we added this much. But by the time that the time step comes, some of it goes away, is absorbed, is gone. Okay? So any amount, any new amount, is the old amount, whatever we had, plus what we are adding minus what is gone. And so, of course, this is C of t. I'm going to change the n to C. Okay, that's the first thing I want to do. And now, C sub t plus 1 is C sub t plus inflow, which is 8 minus outflow. Now, K is gone. K is the fraction. For example, A is 10%, so minus 10% of that. 20%, 20. So minus K times C sub t. Pay attention to this. This is a fraction. So this has to be multiplied by the amount that was in there before we give the new dose. So a quick recap. N of t plus 1, that means the new one, the new step has the old one, plus what we are adding minus what goes out. What goes out is a percentage of what was in there, minus K times C sub t. So C sub t plus 1 is C sub t plus A minus K times C sub t. If you combine these two by factoring, you get C sub t times 1 minus K. That's the basic factoring. I hope everybody's okay with that. So if the initial concentration is C sub 0, 120 micrograms per milliliters, and A, the amount that we are adding is 80 micrograms per milliliter, and K is 1/2 the fraction that is absorbed, plot some points on the graph of C sub t. In other words, find the first few, and then you can do the graph. So what happens is we are going to go to this one and replace what we have here. So first, let's write C sub 0 is 120 micrograms per milliliters. A is 80 micrograms per milliliters. K is 1/2. And now into this formula goes K, which is 1/2, A, which is 80. 1 minus 1/2 is 1/2. So what it means, 1/2 is gone, 1/2 is left. That's really the meaning of it. Normally, this K, the amount that gets absorbed is more than 1/2. But anyways, having said that, so we have 1/2 C sub t plus 80, and the initial value, C sub 0 is 120. So the next one would be C sub 1. See, C sub 0 is given. The next one is C sub 1. C sub 1 is half of C sub 0 plus 80. That means half of this, 120, 60, and 80, they add up to 140. According to this formula, C sub 2 is half of C sub 1 plus 80. So half of this, 140, is 70, and 80, 150. The next one, C sub 3, is half of C sub 2 plus 80. That means half of this, 75, and 80 is 155. So, and you continue, you look at a few more, and you plot those pairs. Now, what is interesting is that, yes, it's getting larger and larger, but does this continue indefinitely? Because if it does, it might be more harmful than helpful as far as the patient is concerned. And the answer is no. As t gets larger, as we go to infinity, C sub t becomes A over K in general. The sequence converges. A, AD divided by K 1/2 becomes 160. And it creates this is the horizontal asymptote, A over K, 160. Okay, I'm going to quickly look at the proof. You're not responsible for the proof yet, but we will make some sense out of this afterwards. Okay. All right. We look at this one and we put it here. C sub t plus 1 is C sub t times 1 minus K plus A. So as t gets larger, that means t goes to infinity. Assume the limit exists. The limit of this as t goes to infinity is the same as the limit of this one as t goes to infinity. And at some point, things don't change. That's the concept of a horizontal asymptote. So we are going to take a limit of this one, both sides. And then this portion, this is equal to L, any variable that you choose, X, Y, Z, L. L stands for the limit. And so is this one. So you replace this one with L and this one with L. And now if we distribute on the right side, we get L minus LK plus A is to cancel each other. And we get 0 equals minus LK plus A. And if you solve for L, you get A over K. This is what we discussed here. And again, as I mentioned, we will look at more examples discussing this concept later. What is important to understand is that because of the time step, we can't have unlimited amount of medication. It has a limit which is safe for the patient.